Hey guys, welcome back. Last time we worked on the scripting layer of Basis, and we made it possible to add small pieces of functionality written in AngelScript to our GameObject components written in Zig. And the idea here is that you can add functionality to the data side of the game. You don't have to hard code all the logic into the game itself. Rather, you can put some of that in the data. And since that video, I have worked a bit more on the system. I implemented some of the missing features, filled in some of the blanks. And I think the system is now good enough for us to actually create something with it. So let's do a little bit of dog fooding today. Let's create a mini game of sorts. A mini game in the sense that it will be a small self-contained piece of gameplay that we will implement inside of means. Nothing super complicated, just complicated enough that it tests out the systems that we created and we can see that everything works. So should be quick and fun to do. Before we do that, let's create a new folder for the minigame. So here we are in the work folder root for means. All of these folders are essentially resource packs. These folders that start with a double underscore, they are sort of part of the engine. But these guys here, they are essentially the root folders for the whole data structure. And if we create a new folder here, we can call it simply minigame. And that means that minigame gets its own resource pack. I think what we'll do here is we will actually open up our prototype level, the one that we usually look at. It's actually in here, isn't it? No, it's not. It's here in prototype, yes. So we'll open this up and we'll actually save it in the minigame folder, minigame, like this. And now we can see what it actually created. So we have minigame, we have a basis level. This is the work file, like the document that this editor actually opens up. You have some binary data. There's a nav mesh that we don't really need. We can actually get rid of that. We have the terrain here. I think I'm gonna delete the nav mesh object here. And actually we can delete all kinds of things. Let's delete this layer. Let's delete that layer and that layer. Let's essentially delete almost everything. The reason why I went this way rather than creating a new one is that we have pretty nice ambience settings already set up in here. So it is pretty easy to just use this. So what we'll want to have is the terrain, sky sphere. We can have the ambience controller. Let's move it up there. Test vehicle. We can get rid of those. We don't need the terrain carver. Blah 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 blah. Maybe we can keep the kill plane there if something happens to fall off the level, like this. And I think actually we'll even just level this out. So we'll record that and then let's put up the strength and we'll just level this out like this. So I have essentially just this one big plane here, and now we can save. Okay, so the next thing would be to model the arena. How do we do that? Let's do that with a quick mesh. I'm going to verify that this sits at 0, 0, 0. So I'm going to put that in. I'm going to move it to 0, 0, 0, and then I'm going to move it up so that it sits roughly on the terrain. It doesn't need to be exact. Roughly on the terrain. We can save that. Let's call this arena. And I'm going to open up Blender. And here we have our basis Blender sync server that we can enable, and we can click edit in Blender and it should momentarily appear. Actually, it did appear. It is this thing. Let's cancel that edit. I'm gonna want to include some of the surroundings, and I think the vehicle that we will use for this is the test vehicle. Let's put one of those in here just to have the scale, sort of get a good idea of the scale, how big we need to make this arena. Like so, and we need to include the surroundings. Let's have maybe 100 world units radius, and now if we edit in Blender, we should see some more objects here show up. Like this, we do indeed. Typically what I like to work with is using the random colors. Some of these things can be kind of a little bit difficult to see depending on the lighting, but you get this nice contrast between the actual object that we're working with and then the rest of the things. So what we'll want to do here now is go into edit mode. We can essentially delete all of these vertices. We want to add a cylinder. I was thinking we would make this arena round, like circular. So let's make the radius really big, something like I don't know. It was 50. It was 100 that we took for the included surroundings. Maybe we can make this 50 then. That should be fine. 50 is not 0. No. I'm being bad at Blender here. Let's make this 50 like so. And yeah, that's probably fine. Then we can take this top face and this bottom face and we can inset those like so. We can actually probably we can do better than that. We can just remove the bottom face, use the top face, inset it and extrude it downwards like this. Then we can maybe inset it some more. Let's make some kind of pedestal here in the middle, like this. And what should we do with the pedestal? I was thinking, like, when we have actually collected these things, maybe we'll have like a fire or something that is lit here in the top. That could be kind of fun. That could be kind of fun to have. Let's use that, and we can scale that in like so. I don't want to spend too long on this because it's not really relevant to our testing of the script system, but I mean, you get kind of carried away when you start doing these things, and then it's just fun to mess around with. Okay, something like this, right? So now we have a clear sort of arena here to sort of play around with. Now what we can do is we can finish editing like so, and voila, we have it in the game. We have it in the game. So now we can enable physics for this guy. Try mesh. Default is probably actually correct. Maybe we can make a default ground. Default ground you can actually drive on. So if someone drives on top of this, like here, then it should technically work. We can try this. Try this out. And there is our vehicle. And we should have collisions, which we do. Yeah. I'm gonna lower the volume for myself a little bit. All right. So here we have our arena for our minigame. Very exciting. So the logic that I'm going to use to actually just to spawn these spheres is going to be super simple. So I don't want to. We could very well just start messing with this terrain here and make like bumps and all kinds of things. But I don't want to do that because then we have to actually really use like the nav mesh or something to figure out good positions. Here we can just do them like a set distance from this center, and that should be fine. So let's not make this too let's not make it more complicated than it needs to be, shall we say? All right. So now we have this. Let's hijack this Blender instance for one more thing, and this is very quickly make a new model here, like this. We will make it not a circle but a sphere, right? And we can make like an icosphere. I guess these guys look kind of interesting when you make them really low poly. So this almost looks like a diamond, I guess, or something like this. Yeah, let's call these diamonds. That's good. So we can save this now. And we'll go into projects, basis data, means data, and we go into minigame. And in here, let's create a new folder called _work. In here we can put all kinds of things, and the game won't try to actually use these files as like data files. And we'll just call this diamond. Yeah, diamond Blender file. And then we can export this guy. And let's export it as an FBX, and we'll move it outside of the work folder. And I don't actually have any operators here, so let's actually make some operators. Let's do only the mesh, only the selected objects. Z is supposed to be forward, and yeah, I think that's it. So we can call this something like basis mesh, because that's essentially what basis expects us to do. Z forward, Y up. Looks good. Okay. Okay, that's good. What then? Now we could perhaps create a type for that. So let's go into the asset browser, open this up, and go into blueprint, and we can do maybe gameplay blueprints. Actually, let's add one more blueprint file for minigame. Let's keep this minigame thingy sort of separate from everything else. The way you create blueprints currently in the engine is kind of clunky. You need to actually create a JSON file yourself. Let's see, blueprint. So now we have minigame blueprint. We can add an object here. So let's call this minigame /diamond. Right. So this will have a transform, yes, which will exist on the client and the server. All right. Let's add a mesh component here. Mesh component, yes, that's the one. And for the mesh, we want the diamond, which we just exported. For the materials, I don't actually have a good material yet. What do we use? Do we have some kind of default material? That might look weird. Let's use that for now. Let's see how that works. Actually, we can try to connect to the game here and see if, yeah, it looks like this. It's not very fancy, is it? Maybe we can make it just look a little bit more diamond-like. So what we'll do is we'll open up probably the. So we're in slide now. That's not good. What was the project that I opened this up with? It is actually means. We just happen to be in the wrong game projects folder. Let's go into means. and we go into game and materials, and we can do just base material, probably color. Yeah, we don't have any light probes. That's not really a problem. We can just use, let's use like a specular. Like this. Diffuse texture. Yeah, okay. So now we can create a variant of this guy. And we'll save that variant under the minigame folder. So diamond, probably, and we can set this color to something. So this is the diffuse color. Let's set the diffuse color to something like that. Ambient color, something a little darker maybe, something like that. And then we should be able to go in here and it hasn't actually. I need to probably open this up again so that it refreshes the list. Let's go here and diamond. No, alright. Reload component UI definitions is probably not what we actually want. Let me just shut that down and open it up again. It probably just didn't realize that we had actually gotten a new material. Oh, you know what? I know the reason. We haven't exported it yet. So now we have diamond. Yeah, material exported successfully. So now it should be there. And we can't see it yet, but we bet we can do that if we restart one more time. Minigame and diamond. I still need to actually write it here. And there we go, diamond. All right. Right, there we go. So now we have the color looking maybe a little more diamond-like, and we can of course just edit these things now here on the fly. Let's make that a little smaller. Something like this. We can see the changes there, but they're very small. So anyway, let's not waste more time on this right now. That works. So now what we can do is we can reload the data files here, and we should be able to place these diamond guys into the scene. So they look something like this, and this is good. I also think that this height is something that we can probably adjust here. So like the Y component. Yeah, it should be 51. If their Y component is 51, then they are sitting at a pretty good place in the level. All right, that's good. So how do we make it so that the player can actually like pick them up? And I was thinking that we could just add a trigger component to this guy. Trigger, like so. And probably don't need it on the client, I don't think. We don't need it on those. We need it on the server. So the server is important. And now if we... yeah, sure. We reload this one more time, and we actually place one of these diamonds in the level. We should see that it has... This guy now has a script. And not only does it have a script, it actually has a physical trigger. You can see it sort of poking through, and it's very difficult to see. And the reason for that is that it is currently a box, and it's quite small. Let's make it a sphere. And yeah, I think that is probably quite good. Sphere with radius 1, and here we can actually script what happens when the player actually like drives into one of these guys. So just as a test, actually let's not do that yet. Let's write something here. So when object entered, we can just do print maybe self get game object. I think it's get name, I think. No, it's get own name hit, something like this, right? So it just reports whenever it actually was hit by the players. We should see the output here in this corner here. So now if we drive into that, you can go, oh, base diamond 1 hit. All right. Okay, so that's cool. It's not super useful to us right now because we're not gonna individually place these guys in the level and then script them individually like this. But it's a good start. We can detect when something is hit. All right. So, what's the next thing? Let's save the level. Let's go into Zig and create a component. So we're gonna need some kind of centralized place to put the logic for the game mode. We're not going to script everything. We're going to have a Zig component here, which we can script, and that Zig component is going to sort of sit here and manage like the session, the gameplay session. So we'll call this minigame logic.zig. Maybe minigame logic component, right? Like so. We can create a component, minigame logic component, and we'll call it means.minigame logic component, like this. All right, so let me just create a new window here, and onto that window I will drag this expose property test component. So I'm basically just going to have this as a cheat sheet. Actually, let's drag this off to the side. Since I'm sort of doing some of these things for the first time, or shall we say second time, because we did it in the previous episode. I'm going to keep that component that we worked on last time as a cheat sheet for how to do some of these things. All right, so this is the thing that we're going to be scripting and exposing some functionality to the script so that we can actually drive the gameplay logic. So we are going to need a script code container. So let's call this script code, and it is of basis.angelscript.scriptcode. And we need to add this to an exposed property, like we talked about last time. So exposed property map. And the reason for that is that so that the editor actually realizes that we have one of these things, and it can serialize and deserialize, etc. Handle the script for us. Into the map we put basis, exposed properties, and script code property is down here. Parent type is self. The field name is script code. So it refers just to this guy here. You might be thinking that this is kind of flaky, like if you mistype this, then it won't work. But there is actually some comp time code verifying that getting the field by name essentially. So you can't really misspell it. Basis, AngelScript, script code template, and script is fine. Version is 1, and we don't need any options, and that's basically that. So that is one thing. The other thing that we need to do is we need to add the register AngelScript method here, which is needed if you actually want to have this registered as a scriptable component. So AngelScript, and this guy takes a registration. Basis AngelScript component registration, and this is something that maybe I could have like a handy snippet for or something, but I don't currently. So here we need to give this type a name. Typically what I use is just this minigame logic component. It needs to be unique, but unfortunately it can't be this with this dot here. It's not a valid AngelScript name. So let's think about some things that we will want to script. We want to probably want to start the game. with a script command. So let's do registration, register component method, put in some method here, and we can simply call this void start game, right? And we'll want to put in a function pointer, which we'll get to in a little bit. And then the other method that we'll probably want to have is void diamond hit. So basically, if we go back here, we have this object type here. When object enters this volume here, this diamond object type is supposed to report to this gameplay logic that hey, I got hit by this object here. Please register, etc. And so let's go back here, and we can do. Right, we need to know first of all the game object that was hit. So it is essentially the diamond which was hit. And here is how we can actually pass in a game object reference in Basis. Game object here, this type is something that is registered as a scriptable value type in C++. This type doesn't actually exist in Zig, which is why it becomes a little complicated to actually get like if you have a method like called diamond hit in Zig, what would you actually put here, because this type doesn't exist in Zig. I'm going to show you how I solve that in just a little bit. But before we do that, let's move on. Let's write collider. So this would be probably like the player's car in this case. So diamond was hit, we pass in the diamond, and we pass in the collider, and that should be probably all we need for now. So let's create the methods here. I'm going to move them down in a little bit, but let's create them first. So let's call this fn underscore start game, and this will actually be, let's call it underscore basis int pointer. I'm going to explain the underscores in just a little bit. And this would be a void, like so, and we can just do ignore the self parameter for now, and we will register that as the start game function. Then we will have diamond hit, and again we will have self, which is a basis int pointer. Then we will have diamond, and here I've introduced a new type, which is it's really just an alias for usize. You can see it here on the right side. This is really just a usize. Game object ref const int, game object ref const in. So you can see it's a game object referenced game object reference constant and in. Yes, that's a mouthful. And then we have a collider, which is of the same type, like this. And this would also be call convention C and void. And we will register that with the script as well, like so. There we go. Okay. So now, why the underscores? Well, as we talked about last time, we need to have these wrapper functions, and I mentioned that I actually didn't need the wrapper functions last time. Well, now I do, because I've made it so that you can actually bind AngelScript methods to both the Zig component, which is what we're looking at right now, as well as its C++ counterpart. which is how you get to all kinds of standard functionality. You don't have to like add, for example, if we go here and you just hit like self, you get all kinds of like create game object, destroy self, is multiplayer, print debug info, all of that stuff. You don't have to actually add that to your Zig code. You get some of that stuff for free, and that is bound to C++ code. And because of that, because we have this weird dual pointer here, we need to do a little bit of work to actually resolve the actual self pointer. So for start game, it's kind of easy. Well, it's always kind of easy in a sense. This is the function that we actually want to run, start game, when someone executes start game in the script. We bind it to this underscore start game, and what underscore start game does is it resolves the proper self pointer, and it does it by calling basis angel script get component self. The type is just self because it's the same. It's aliased up here like this, and the pointer pair address is this. So it's a pointer pair because it contains essentially both the C++ and the Zig pointer. You need to select which one you want. Once we have that, we can actually call the proper function, so start game. And we call self.startGame, which calls this guy here. So it's a little more complicated currently than I would like. Maybe we can do some magic with Zig comp time stuff and actually sort of almost auto-generate these wrappers. That would be kind of cool, but I haven't done that yet. I've concentrated on actually making it so that I can get this working first. Actually, these probably don't need. These shouldn't be const. They should probably be actual pointers or mutable pointers. Right. So now we get to the interesting part with this. We have this diamond game object reference that comes in here, and we don't actually have this type in Zig anywhere. The way it is handled currently is that all the game objects can be identified by their name or their path, which is essentially this. Like this has copy full path, and you can see base : diamond 1, which means that we can just treat these as strings for now. Maybe we'll actually implement these types later on in Zig, but I don't think I necessarily will ever do that, because really what you're interested in is the path. When you have that, you can do anything. You can get like the pointer to the actual object, etc., etc. And yes, so what we'll do is we'll do the same kind of thing with self there to resolve the proper self. Then we can do const diamond without the underscore. And we do basis angel script get game object ref const in, and that would be underscore diamond, and then const collider is basis angel script get game object ref const in underscore collider, like this. We don't actually want that. We just want to do self diamond hit and diamond. Oh, come on. Visual Studio Code is being nasty. Like so. All right. So now we have our proper methods. Let's maybe move them above the wrappers like this. This function here and this function here, and these two are the wrappers. But yes, this is now kind of interesting because now we can actually like refer to, because these are game object references, you can actually get auto completion for objects that are in the level and so on. So that's kind of nice. Let's add this to the components list. Let's just do pub const, then something is import minigame logic component dot zig We have minigame logic component there. Now we can copy it there. And we'll add it to the list of components to be registered. And we make sure that we can build it, which we can't. Right, I'm not initializing the script code. Member, so we'll need to do that. We'll do script code is basis ng-script. Yeah, it is actually ng-script. And init, and we need to pass in the context allocator to it. In destroy, we need to do self.scriptcode.dinit. And with a little bit of luck, that is everything that we'll need to do. Let's see if that is so. Maybe we could do something a little interesting here. Context print. No, what was it? I don't remember anymore. It's like basis UI debug overlay. There we go. This is what I was. So debug trace. Game started, yay, and then that needs to be an empty tuple. So just to sort of test that we are running the game, let's just print game started onto the screen when we run this command. Okay, so provided this now builds, we should actually be able to create one of these guys and put them in the level. We actually can't, huh? Oh, access is denied. Yes, and that is because we are actually running the editor here. So what we need to do is we need to unload the backend, as it's called. So now the editor is still running, but the engine was shut down. I can click here to reload it, but let's not do that quite yet. Let's build this, and in the meantime, we can copy this string here. We can go back to our blueprint, and let's call this minigame logic, like so. And it doesn't need a transform, we can just delete the transform completely. Let's add a new component and paste this in. And we can just call this logic. And it will complain that it's not a registered component type. It is registered in the sense that we added it to the components list in Zig. Oh, we have another problem here, it would seem. Let's look at that in just a sec. We added it here, so it's registered and it can be used, but it's not registered here because we haven't created like a UI definition for it. But yeah, that's just a warning. It tells us here that we can add a UI definition to modify its properties. Well, it doesn't have any properties, so that's fine. Yes, this guy is the thing that is actually complaining here. So it was the reason we couldn't build it, and it crashed because it wasn't included. It wasn't registered because it couldn't build it. So it was a chicken and egg situation going on. Now we should be able to run this again, because now it's properly built, and you can't actually see anything, but that doesn't matter. We need this only on the server, and we can make this a singleton. So now this minigame logic is something that you can only ever place once in a level, which can be quite handy. And yes, this is, I think, the only thing that we'll need. So now we can go back to the editor and reload this guy. And we can do diamond and logic now in the minigame category. Okay, so let's add one of these guys here. I'm just going to call that logic. So, how should we actually, how should we start this game? How should we start the game? Should we do something fun? I'm contemplating doing something fun. Maybe we can do something fun. I was thinking we could add like an entrance here, but this thing is getting a bit complicated already. So let's just let's do something easy first. Start minigame is what we'll call the function that we will run to actually start the game. And what we'll call here is simply self.startGame. And you can see that I've implemented now the auto completion for the methods that we bound. So we can do that. So now just by adding, just by having this registration here, start game actually makes it appear here in the auto completion list. So that's pretty nice. So now if we run the game, we can see here start minigame, and if we click that, it says game started. So yay, our component is running. Pretty cool. Okay. So now that we have this working this far, I think what we actually want to do now is we want to spawn a vehicle in the level. We don't necessarily want to actually use the one that we have there, or do we want to use that? Maybe we want to use that. Maybe we can use that. So we have this thing here called test vehicle. Test vehicle 1, we can just call this player. Right? That's the player. I mean, we could spawn one of these if we wanted to, but let's not be unnecessarily complex. So now it's called base player, base : player. And the name comes from the fact that it's sitting on the base layer, and the object is called player. So base : player. That is the object that we want to use as our vehicle. And the way we do that is quite simply by let's paste that there so that I don't forget what it is actually called. We can set it as the single player avatar, right? And I wonder, should we do that? Should we do that here from the code, or should we do it from the script? Maybe we could do it from the script. That is perhaps the easier thing to do. We should be able to do it, yeah, set avatar object. We can do it here. That's probably fine. So it wants a string hash, because these things are typically sent over the network. So we want player vehicle hash, right? And that would be basis string, make string hash, and then the string hash is base : player. So we'll want that, and the host ID is 1, because this is a single player game. So that's cool. I think we should have a little bit of state management going on here. So let's add a comment here that exposed properties is what we have here, and then above that we have just normal members essentially. So state like this, and the first thing that comes to mind is game active, right? With the bool. And it's initialized to false, like so. So if someone tries to start the game and it's already running, then we can just return. But now we can set it to true, like this. All right, and the other thing that we'll want to is game time, right? This is probably a float, and it's probably initialized to 0. So we set, just to be sure, so to speak, we'll reset it here. And in the tick method, which gets called every fixed update when the game is not paused, we do if self game active, we can do self game time plus equals tick delta time. Oh, tick delta time, like so. So that should be that. Then we have some more state. We have diamonds collected, right? And this is probably an unsigned integer. And again, we reset everything here. What else? What else? I think we can probably get quite far already with this state. So let's do that. Now we should probably add a function here to spawn the first diamond. So let's add a function here. I'm gonna call this. This is like the scripting API, right? Script API to the object, because these guys here, they correspond to what we have here. And then we have just plain old normal member functions down here. And we have spawn diamond self. And yeah, this thing might actually throw some errors, so you might want to have to do it like that, but I'm not gonna do that yet. Let's try to figure out if we actually need that. So the first thing that we'll want to get a reference to is the game state object, and we can get that through the context. So game state, and we'll want to probably hard code somewhere here the name, so we can copy the name. Minigame diamond is the type that we'll want to spawn. Let's put it up here before all of the actual data. So pop const is like diamond object type, and that's just a string. So minigame diamond. Right, and we will want to create. There are a few ways to create game objects. You can just give it an object name and an object type. I think in the end we will want the most complex and flexible version of all of these, and that is to create something called a game object creation parameters object, which is an object that really lives on the C++ side, but we can create one from here and pass it on. We can configure all kinds of things. So let's do that. Let's do basis game object creation parameters pointer, and we init a new one. And so that I don't forget to delete it when we're done with it, we will do a defer dinit like this. And a diamonds. Actually, we can probably don't need to do that part. We can do init with name and type. And so the object type is that's like diamond object type. That was the name we gave it, right? Yes, up there. We need to generate a name for it though. So actually let's have that as a state. So we can have what do we call this? Current diamond object name. And that is a string. A string with a big S. So this is a struct that can actually like dynamically allocate memory for the string contents, and that's why we need to actually initialize this with an allocator. So context allocator like this, and of course we also need to deinitialize it later on. So not a typical zig string like a U8 slice like this, but an actual fat game, like a fat dynamically allocating string struct. And in that dynamically allocating string struct, we will want to do game state generate game object name, and we can just call this diamond. So it wants a prefix, which in this case is diamond, and then it wants a random part length, and that is so that it can generate a unique name, and let's give it something like 4 maybe. And now we can use the object here, but it actually wants the typical zig string, so a const slice of unsigned integer 8. So we will want to use str to convert it to that. Let's put a comma there to format that a bit nicer. Right, and yeah, that's that. And now we can use game state to actually create the game object. And we'll want to use the correct version of it. So create game object with parameters, and that would be diamond params. And we need to give it some kind of starting transform, right? So it wants a position and an orientation. Okay, so let's do const x is, and so we wanna spawn it. I can probably just reload this for a second. So this thing is sitting at 0. That's the x coordinate. So this way, and a 0 at z as well, and then some distance upwards. And we already determined that the y coordinate needs to be 51. It has somehow drifted a bit higher, but yes, y coordinate should be 51. So that's good. Like 0 there. Const y is 51. And we can figure those out in just a sec. To the diamond params, we will now set the start transform. So this can just be x, y, z. Nope. No, thank you, Visual Studio Code. I don't know exactly how to use some of this auto completion stuff yet. For the orientation, we can just use the identity quaternion, so it's essentially not rotated. All right, so we'll want to randomly select it, and I'm just going to do this very naively and just select a random x and z coordinate for now. And we can do something more fancy later on if we want to. But to be able to do that, we will need a random number generator. So random number generator. And we can do basis.math.prng, yes. And I think this thing we can initialize with, if I remember how I did this. So it's prng. Actually, is it math? Init new prng, yeah. So that's how you get a new RNG, and it's initialized with initialized with random bytes provided by the OS. So should be random enough for our purposes. And then here we can do basis math. What does it get? Random float, yes. And then prng, we want to call random on that. No? What? I think that's how it works. Let's see. Oh, right. I forgot the self there probably. So get random float. It's self.rng.random. Yes. And minimum, well, minimum is now. What do we say about what do we say minimum is? Let's do minimum is 4, and maximum is 45. So minimum is 4, and maximum is 45. And then we need to same thing for the Z, and we need to do also negate those based on some criteria. So let's do this is math. This is math. Get random float. Self RNG random. And we can do just 0. 0 I'm just thinking how this should really be done. Just do something like this, so that if it is over half, then x is minus x, right? Something like this. That should be fine. Then we do the same for z. It's not a very elegant way to generate a random position, but I think it will do. I think it will do for now. Okay. Cool. So now this should actually probably already spawn a diamond properly for us, but of course we need to actually call this guy. So we'll call it once when we actually start the game, and then we will again call it when we hit a diamond. So whenever this is called, the diamond needs to be destroyed. So let's see. Can we do? We can probably do this. We can do var game state. We can do game state destroy game object. Name hash, that would be. We can just use basis string. Make string hash diamond, like so. Yes, and then we want to do self diamonds collected plus equals 1, and we want to potentially actually end the game here, but let's not do that yet. Let's not do that yet. And what we can do here is we can figure out if actually before we do anything else, we need to make sure that it was the player who. Right. So here we go. Let's call this pub const player object name, and it is base player. So if the collider, where's my, here we go. Yes, if something else collided with a diamond, then we need to not care about it. So if I think it is basis.string.equals, and we have player object name, and then we have collider, and this returns, well, there returns a bool. So if it is not that, if something else collided, then we just return. No need to do anything. But if we do indeed collide with a diamond, then we do all of this. And should we maybe put this as a constant up here? How many diamonds to collect? So diamond collect count or something like that. We can even make that as an expose property, so you can adjust it from the editor if we want to, but let's keep it as a constant for now. So if self diamond collected equals diamond collect count, then we essentially want to end the game. So we set game active to false, and for now we can do something fancy later on if we want to. Game ended like this. We can do something fancy and show it on the HUD if we want to. But yes, for now we just end the game, and maybe we can time. or something like your time, and then we do how did we print time? Was it something like D2? Is that how it was? Yes. So 2 decimal places, and we can do self game time like this. So your time, and then you see how long it took. If we don't have enough diamonds yet, we call spawn diamond and spawn the next one, and that one goes in here and does its thing. All right. So that's pretty good. I think we should get pretty far with this. And now if we actually build this and we run the game, I have something. What is the what expected third party? What does it actually want, like a string? No. What's a slice? Yeah, that's fine. Okay, yeah. So this returns a slice, and we set it directly to a string, so that we can do that. But we can set it. So we can just call set, and we can feed this whole thing into set, and that should be fine. And that probably, yes, that can return an error. Okay, so spawn diamond. All right. Yeah, we're going to have to actually do some error handling here, but I'm not going to do that. I'm just going to be stubborn about it and do catch error. Typically I do something like this, and then we do like basis assert false, and we can do error name like this. So this is not really all that beautiful error handling, admittedly. Typically you would these need to be variables. Typically what you would do is you would have this thing also throw an error, this thing which calls spawn diamond, and then this could also return an error. Not throw errors, we don't do that in Zig, but return an error. The problem is that we can't really bind those kinds of functions to AngelScript. You could handle it here in the wrapper, and maybe that's something that I have to do later on, but for now we have to handle our errors like this, which is a little silly, but yeah. All right. Right, so the args needs to be a tuple, and we can just wrap that error name in a tuple, and that'll be fine. Can it slice without a specifier? Well. All right. I got like 5-6 errors, all from the same thing. So that's a little silly, but yes, the whole thing comes from the fact that, like, if we could do this, we just put an exclamation mark there, then we could do like try in front of this, and then we wouldn't need any of this thing. But yes, that should be fine. Now we'll go into the game, and what happens now if let's get rid of this guy. Actually, let's not get rid of him, but let's move him to another layer, like so. That means that this layer doesn't have the lightning bolt, which means that it's not auto-loaded, like now it is, and now it's not. So now this thing won't actually appear on its own. It's in the level data, and we can bring it in if we want to. but it's not there by default. So now we start the game. We get the avatar set correctly. That's really great. I don't know. Did we spawn a thing already? We did, and it's not working correctly, unfortunately. Let's see what's going on. How did we actually? How did we set these guys? So Z and X, 4 and 45, X, Y, Z. I think that should be fine. Let's just do a quick printf here. Do like X, Y, and Z like this, and then we bring that over there. Yeah, because I think it should work, but there's clearly something going on here. Maybe some of you are screaming at the screen, telling me where the problem is, but unfortunately that doesn't help me right now, so let's figure this out. Alright, let's bring that up, and that is the game output. We can start this. Alright, so now it does actually appear inside of that, but it looks a little weird. That the data does look a little weird. I wonder if there's something wrong with my random function. It is possible. It hasn't been used all that much from Zig. Let's do one more. See what we get. Yeah, that looks better. You will also notice that it doesn't actually properly register my hit, and I know why that happens. So that's another thing. Maybe we can fix that first, and then we'll see when we actually can more easily get those hits registered. We can figure out what's wrong with our coordinates. So. Right, the problem here is that if we start to actually script this guy now, first of all, this guy is not really in the game because it sits on this other layer, and even if it was, then we are actually spawning those diamonds from code at different positions, and those diamonds don't have this script here attached to them. So we need to somehow make that happen. Well, first of all, let's actually do what we need to do here in the script. So when the object enters, we need to let the logic object, which is over here, know that it did actually happen, right? And so how do we do that? Well, we can in fact use this script here as our logic, but we need to do it in a slightly different way. So let's send a message. Send message, and we need to send it with you have a few different variants here with different amounts of parameters. I hope I remember correctly how to do this. It's been a little while since I've done any bit of scripting never really in means, more in project slide. It should work like this. So the receiver is, of course, our logic object. That's the first parameter that we want to use here. The second one is the message itself, and that can be anything. It's just a string. We can just make something up. And then we want a parameter, so a param here, which is of type any. And we should be able to just pass the object that actually collided with the diamond there as the param. So for the receiver, we can do level objects, base, and logic. And so that refers to this guy here. Sits on the base layer. Its name is called logic. And we can just hard code it like this because we can be sure that in the minigame the logic will always sit at that address, if you will, have that name. The message can just be hit, for example. It doesn't really matter as long as we're on the same page with the logic about what the message means. And for the parameter, we're just going to be sending the object itself. We can try to build this, and yeah, it builds successfully, so that's fine. Now, on the logic side, we need to react to that message. So here we have if message is hit, and now we can do something with this. So on message, and from the params, we can do get game object. And that would be the collider, right? And now we can just do self diamond hit, and the diamond is essentially this object itself, and then the collider is the collider. So we can do self. No, sorry, the diamond is the sender. So the sender of the objects is the diamond object, and then collider is the second thingy here. And let's make sure that builds, and it does. Right. So now we have sort of the script sort of wired up. However, if we now run this and we try to intersect on these guys, it still doesn't actually work. And of course, the problem is still the same, that this guy is just a diamond that is placed in the level. It doesn't actually exist in the game yet. So how do we make this script thingy here actually work? What we can do is we can create something called a property bundle. So we right-click this object here, create a property bundle, and we put it in the minigame, and we just call this diamond bundle, for example. That will create an object which is turned into a resource because we placed it inside of the minigame resource pack. So we can just click here and we copied it to the clipboard. And now in the SIG code, we can go here and we can set diamond params set property bundle path. And now as we spawn these diamonds, we as part of this params object, we tell it to use the property bundle with this path. And that will mean that it will actually populate the whole object with the properties that we set in the editor, and that includes the script, so it will get the script as well. And it should have that same on object entered, sending the message to the actual logic. So now with a little bit of luck, we should have collidable diamonds in the game. And where is it? Hey, look at that. And it works. And now, interestingly, we do seem to get all of the diamonds spawning in well-behaving places. I don't know exactly what happened with that one object when it went outside of the bounds. I mean, there may still be some weird issues there, but it does seem to work now. So let's consider it a one-off bug. And of course, it is possible now that the when the diamonds spawn, they actually spawn inside of the player's car, which is a little silly. There's no actual handling of that thing. All right, so game ended, and my time was 60:57. Yeah, that's pretty cool. Let's see if can we do another one. Should have. Yep, here we go. Can I beat my record for how quickly we can do this? I mean, it's hardly a fair game in that sense, because it very much depends on where the objects get placed. But yeah, again, just as a sort of test, it looked like I was actually able to run through that wall, but no, it does seem to work properly. That was lucky, and that was kind of lucky as well. All right, yeah, 51, even with me running through the wall. Like that's interesting. Like the wheels are sort of clipping through. I think the thing is here that since this is raycast based, if we make this default rather than default ground, now I probably can't do that anymore. Right, so I don't want to start the game. I just want to make this guy the avatar through other means. So now I probably can't. Yeah, like now it's hitting the thing. It doesn't try to actually drive on it. Okay. Okay, cool. Yeah, maybe this is enough for this video. I think we've proven that the scripting layer works quite well. Some of these things are still a little annoying to work with, namely the wrapper functions. So things like this, it's a little annoying that you have to actually like unpack all of this data. This could be done probably with some generated code that the comp time could do for us. So maybe I'll have to look at that at some point. But yeah, other than that, I think this is already quite a usable scripting API. And considering I wasn't able to script anything with AngelScript and Zig about a week ago, this is a pretty good outcome, I would say. So yeah, that's it. That's our small minigame. I'm gonna end this video now. This is already getting somewhat long. We could improve this quite easily by adding some goofy properties. For example, you could have have a label here on the HUD that we would update using a goofy property, and that would show you the time, for example, and the number of diamonds collected, things like that. But yes, we've seen those things previously in the video series, and so I don't think I'm gonna spend more time on this little mini game for now. I think we can do that with the actual means HUD when we get to it. So let's end this for now. Leave a like, leave a comment, subscribe, do all the things, and I hope to see you in the next one.